The main idea in the last video was really to get you to see the equivalence of a couple different statements. Mainly the conditional if P then Q is equivalent to not P or Q. Right, in the example we had, if you love me, then you will keep my commandments. It's equivalent to either you don't love me or you will keep my commandments. Okay, those two statements are equivalent, the conditional and this disjunction. What we then said is that if you negate both of them, the negations will also be equivalent. That's over here. The negation of the conditional is equivalent to the negation of that disjunction, okay? So the negation of each of these must also be equivalent. But what we also showed is that the negation of the conditional is in addition equivalent to a conjunction with the antecedent and the negation of the consequent. So how we phrased that was, of course, it's not the case that if you love me, you'll keep my commandments, is equivalent to saying either, or that's an and. It's equivalent to saying you love me and you don't keep my commandments, right? So those are equivalent to each other. And so what's interesting is if you look at this sort of with an overview here, you have two different statements that are both equivalent to the negation of the conditional statement, okay? So transitive property applies. You have transitive property in mathematics and logic. Basically, it says if two things are equal to a third, they're equal to each other, right? In algebra, we would say if A equals B and B equals C, then A equals C, right? If two things are equal to a third thing, then they must be equal to each other. Same thing here, basically. So you have two statements, or two compound statements that are equal to the same third statement, then they must be equivalent to each other. So we would say the negation of not P or Q is equivalent to P and not Q. Okay, so how could I interpret that a little bit more broadly, maybe even reducing the number of negations in here a little bit? But what I could say is the negation of an or, right, the disjunction, the negation of an or, is found by negating each part, right? So the not P becomes P, the Q becomes not Q. So it's, you negate each part separately and you switch the or to an and switch or to and, right? So the negation of a disjunction is the conjunction of the negations. Now maybe I could clean that up without so many negations involved. So let's take a look at that. If I just had the negation of a simple disjunction, ignore the negation that's already in there. Let's just say the negation of P or Q, right? That's a little bit simpler. Clean it up a little bit. Negation of an or is found by negating each part. So it must be equivalent to the negation of P, that's that part, the negation of Q, negation of each part, and switching or to and. So the or becomes an and, all right? And so that cleans it up a little bit. So I don't have any double negations here. Often those double negations make sentences a little wordy and hard to understand. So I have not P or Q is not the case that P or Q. That's equivalent to not P and not Q, all right? In the example I had in the last video, I could say it is not the case that you love me or keep my commandments is equivalent to you don't love me and you don't keep my commandments. I guess that would be one way to write that. You could say just a random example. It is cloudy outside, or I am in the building, right? Something random. It is cloudy outside, or I'm in the building. At least one of those two things is true, maybe both. Well, if I said it's not the case, it's cloudy outside or I'm in the building, that's equivalent to saying it is not cloudy outside and I'm not in the building. Okay, so you're negating both of them, putting them in an and. And so we can actually prove this also with a truth table if you wanted to go that route. PQ, not P, not Q. True, true, false, false, true, false, true, false, and then false, false, true, true, and then false, true, false, false. That's P, Q, not P, not Q. If that makes sense. Then if I wanted, let's go P or Q. Well, all I need is one of them to be true, right? P or Q. So that's true, 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 false, right? P or not, or P or Q. And the negation of that, which I'll put in another color just so you can see, not P or Q, is going to be false, 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 true. All right. And then, of course, if I want to go not P and not Q, and not Q, well, that is true when only both of the small parts are true. So I need both not P and not Q to be true, and that only occurs at the bottom. So that's my true. And everything else has a false, so the whole thing, the conjunction is false. All right, and so then you can see that those two columns have exactly the same truth values in the same order. Therefore, these two statements are equivalent. All right. Okay. Now we can use this information. This is what we call De Morgan's law. It's one of two variations. The other variation is what happens when you negate a conjunction. So if you say not a disjunction is the same as the conjunction of the nots, something similar occurs with the conjunction. If you negate a conjunction, not P and Q, well, that's equivalent to not P or not Q, right? So the negation of a conjunction is the disjunction of negations. All right, so these two variations right here are going to be considered De Morgan's laws. Okay, the two laws. So we're going to call those De Morgan's laws. All right, and there are two of them. Now, if you'll recall, De Morgan's laws occurred when we talked about sets in our set theory conversation. And we said with sets, we said that the complement of an intersection is the union of the complements, right? So in set form, we said the complement of an intersection is equal to the union of the complements. Kind of looks like this. You kind of think about this one right here, right? The negation of a conjunction, negation of an and, is the or of the negations. The negation of an and, right? An intersection is like an and, is the negation of the disjunction, the or, right? The or is the union. And then equivalently here, we also had that the complement of the union is the intersection of the complements. Those were the two De Morgan's laws for sets, and you'll see that they're very, very similar to De Morgan's laws for logic. Okay, so De Morgan had a couple very similar ideas here. Okay, so now we'll start applying these to actual statements and looking at equivalencies.